Okay, so this is where 11.6 starts to get hard. So let's do example 20, or sorry, number 24.
Is that log base of 5 or log of 5?
That's log of 5. Thanks. Okay, so I want to solve this thing for x, right? Okay, so the logarithms here are standard logs, so those are base 10, right? Okay, so what would I think I should do? Yeah, I should put a 10 kind of under everything, right? So I should think to myself, all right, maybe I'll do this, right? I'll put everything in the exponent of a 10. So I'm going to get 10 to...
To the 7x plus 13.
Because you got 2 logs.
You guys see that? So I'm wondering, now I'm worried, right? How do I put this stuff in the exponent of a 10? Do I have to put all that crap in the exponent of a 10? Yeah, you better. That's the only way it's going to work. So this maybe the step of 10ing everything, maybe was a little premature. Before I only had one thing over here, right? I only had one logarithm, and so those would cancel really easily. Now I've got this thing, where I've got the 10 raised to the log of 7x plus 13 minus the log of 4x plus 13. And this is all supposed to be 10 to the log of 5. That stuff's chill, right? That's just 5. This thing, though, I can't cancel the 10s and the logs because there's a minus sign in the way.
Isn't that the same thing as multiplying the logs, though?
Yeah, so I should have, instead of doing this step first, I should have applied a log rule to both sides first. You guys see that? So this is kind of an oops. We actually could sort this one out. We could think to ourselves, okay, this is 10 to something plus something, right? So I could rewrite this as 10 to the something times 10 to the something. That's using an exponent rule. You guys want to see it that way first?
Yeah.
Okay, so let's work with what we got. So we'll say, okay, this is the same thing. So here I'm using an exponent rule. Okay? Then I'm going to say this is 10 to the log of 7x plus 13 times 10 to the minus log of 4x plus 13. And that's, what was the other side? 5. You see that? Okay, now this piece can cancel, right? So I'm going to get 7x plus 13
Times 4x plus 13.
close. There's a problem with that one that there's a negative out here, right? So those can't straight cancel. So I might think about times 1 over 10 to the log of 4x plus 13. Right? That's how I get rid of negative exponents. I put them in the bottom.
Nice.
You guys see that? And then this is supposed to be 5, right? Now these two pieces undo each other. Right, so I'll get 7x plus 13 over 4x plus 13. And that's supposed to equal 5. And now this is a kind of solve the rational expression, like a 9 point something type problem. You guys remember these? Kind of. Okay, so let's do this one. What do we do to both sides? Good, we multiply by 4x plus 13, right? So we get 7x plus 13 is 20x plus 65. Then what? Solving for x, so I should
Subtract 13 on both sides? No?
I don't know, it doesn't matter. So there's lots of options, right? To keep the x's positive on this side, maybe I'll subtract 7x, right? So I'll get 13 is 13x plus 65. Then I'll subtract 65 from both sides. So I'll get 13x is 52. Negative, thank you. And then I, what both sides?
Divide by 13.
Divide by 13. So I'll get x is negative 4. You guys see that? Okay. Cool. So that was with exponent rules, right?